Okay, let's dive right into this explainer. Welcome to your ultimate strategy session for navigating what can only be described as the treacherous Mad Max-style wasteland of the Cambridge IGCSE Mathematics exam. We are talking specifically about syllabus code 0580 today. Whether you're staring down the core or the extended paper, you know the feeling, right? You open the booklet, the clock is ticking, and suddenly the syllabus feels like an endless, unforgiving desert of tricky questions and confusing numbers. But honestly, don't worry. Today, we are going to crack the code on two of the most critical, foundational topics that examiners absolutely love to test: indices and standard form. And to help us out, I want you to imagine two completely different students taking this exam. Let's call them Alex and Sam. Now, Alex is the kind of student who overloads on raw math facts, but completely lacks strategy, writing down entire pages of working out, completely ignoring the clock. Sam, on the other hand, Sam rushes. Sam panics, speeds through the paper, and completely misses the specific command word requirements, losing easy marks left and right. Today, we're going to look at their mistakes so you don't make them. By the end of this session, you won't just be surviving the math exam. You'll be claiming your grade treasure.
So, here is our survival map of the wasteland. We're going to logically break down exactly how we'll conquer these topics step by step. We'll kick things off with the three index laws, then move into the traps of zero and negative powers, followed by fractional indices. After that, we'll tackle solving exponential equations. And finally, we'll hit the boss level, mastering standard form and calculating in standard form. Every single one of these sections is packed with easy marks, provided you have the right strategy.
Let's get straight into it. Section 1, the three index laws. We are going to start with the fundamental rules you absolutely need to survive. These aren't just arbitrary formulas to memorize blindly. They are the logical rules of the road. Understanding these is what separates a student who spends 5 minutes on a 2-mark question from a student who solves it in 30 seconds.
First things first, the crucial point is establishing our shared vocabulary. Let's look at the notation. When you see 5 to the power of 3, that big number at the bottom, the 5, is what we call the base. The little number floating above it, the 3, is our index. And just a quick grammar check for the math world. When we talk about more than one index, we call them indices. It's simply mathematical shorthand, so we don't have to write out 5 times 5 times 5. It saves time. And as you know, in a Cambridge exam, time is literally your most precious resource. Our friend Sam tends to rush and multiply the base by the index, saying 5 times 3 is 15. Don't be like Sam. It's a power, not a multiplier.
Okay, this beautifully illustrates the big 3 laws of indices. You will use these constantly, and this is where we introduce our mathematical adaptation of the PEL framework to secure those top marks: point, evidence, explanation, link. Your point is identifying the correct law. Your evidence is applying it to the base, the explanation is showing you're working, and the link is ensuring your final answer matches the exam's command word, like simplify. Let's look at rule number 1. When multiplying terms with the exact same base, you just add the powers. 4 cubed times 4 squared gives you 4 to the power of 5. Simple, right? Rule number 2 is the exact opposite. When dividing, you subtract the powers. 2 to the power of 5 divided by 2 cubed leaves you with 2 squared. And rule number 3, when you have a power raised to another power, like 4 squared all inside brackets and then cubed, you multiply those indices together, giving you 4 to the power of 6. Alex would write out every single 4 and count them up manually. Don't do that. Decode the command word, apply the law, and move on.
Moving right along to section 2, zero and negative powers. Now that you have the basic toolkit, let's venture into slightly more dangerous territory. Examiners love this section because it tests if you truly understand the concepts or if you're just a robot repeating patterns. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the wasteland. Look at this question. It seems like a trick the examiner would throw at you to ruin your day, doesn't it? What is a to the power of 0, or 5 to the power of 0, or 1,000,000 to the power of 0? Your brain might instantly want to shout 0 because you're used to regular multiplication where anything times 0 is 0. But remember, indices don't play by the rules of basic multiplication. Here is the amazing mathematical magic trick: anything to the power of 0 is exactly 1. And the best part? You don't just have to take my word for it. It's perfectly proven by the very laws of division we just learned. Think about it logically. If you take a number, say a, to the power of m, and divide it by the exact same number, a to the power of m, we know that any number divided by itself is simply 1. But if we use our second index law for division, we subtract the powers. M minus m leaves us with an index of 0.
Therefore, a to the power of 0 mathematically must equal 1. It's perfectly logical. Our rushing student, Sam, would just write 0 and lose the mark, but now you know the secret.
And this builds our understanding further right into our next trap, negative indices. 4 to the power of -3 does not equal a negative value. I repeat, it is not a negative number. Instead, that negative sign is actually just a set of instructions. It forces the base down into the denominator of a fraction. It literally means flip me over. So 4 to the -3 becomes 1 over 4 to the power of +3. Once it moves down below that fraction line, the negative sign has done its job and disappears. Remember this rule and you'll easily step right over one of the most common pitfalls that trips up thousands of students every single year.
Let's conquer Section 3, Fractional Indices Explained. Let's move to fractional indices and see how they are actually just a secret code for roots. This is exactly where Alex's lack of strategy kicks in. Seeing a fraction in the air causes sheer panic. But watch how we decode it.
When you see a fraction up there in the power, don't panic. The denominator, that's the bottom number of the fraction, tells you exactly what kind of root you need to take. So a power of 1/2 simply means you take the square root. 16 to the half power is just another way of writing the square root of 16. And what's that a very manageable for? If the power was 1/3, you'd take the cube root. If it was 1/4, the fourth root. It's just a disguise. It's the exam board trying to see if you can translate their mathematical code.
Let's look at a slightly more complex one, where the top of the fraction is into 1. 125 to the power of 2/3. This is where we use our mathematics success blueprint, step-by-step logic. By breaking this down into 3 simple steps, taking the root first and then applying the power, even the scariest fractional index becomes totally harmless. First, we look at the denominator, which is 3. That means we take the cube root of 125. What times itself 3 times equals 125? 5. Next, we look at the numerator, the top number, which is 2. We take that result we just got, the 5, and we square it, giving us our final answer of 25. A massive pro tip here. Always do the root first. It makes the base number smaller and way easier to work with without a calculator.
Welcome to Section 4, Solving Exponential Equations. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right. Armed with these laws, you are now ready to hunt down unknowns. We are going to solve equations where the variable x is hiding up in the index itself.
The ultimate survival trick here is finding a common base. Let's say you get an exam question like this. 2 to the power of x equals 32. We can't solve it directly as it is, because the x is trapped up in the air. But if we put on our strategist hat and recognize that 32 is actually just a power of 2 in disguise, specifically 2 to the power of 5, we unlock the whole problem. We rewrite the equation as 2 to the power of x equals 2 to the power of 5. Since both bases match perfectly, the math rules say we can just drop them entirely. Therefore, x must equal 5. Boom! 2 marks in the bag in less than 20 seconds. And hey, even if the examiners try to escalate the difficulty by putting an algebraic expression like m-1 up in the power, applying our exact same strategy guarantees you the marks. Look at 3 to the power of m-1 equals 81. What's the goal? Find the common base. We know that 81 is 3 to the power of 4. Because both sides now have a base of 3, we literally just lift the indices off and set them equal to each other. It becomes a basic linear equation. m-1 equals 4. Add 1 to both sides, and m equals 5. Alex would try to guess and check numbers for 10 minutes. You just apply the common base strategy and sweep up the points. Which brings us to Section 5, Mastering Standard Form. Now we reach the absolute boss level, using indices to tame the most gigantic and microscopic numbers in the universe. This is a massive part of the 0580 syllabus, so let's get focused. Look at your screen. Let's do a quick 60-second mental data scan challenge. See how standard form takes a clunky number on the left, like 72,000, and neatly packages it into a mathematically elegant expression on the right, 7.2 times 10 to the power of 4. It instantly tells us the significant digits, and the power of 10 tells us exactly how big the number is. No more counting endless zeros with your pen during a high-pressure exam, which is exactly how people make silly errors. If you scan any Cambridge paper, you will see data presented like this. It's the language of scientists and examiners.
But listen closely, because standard form has a strict bouncer at the door with an absolute, unbreakable rule. To be in proper standard form, it must be written as a number, a, multiplied by 10 to the power of n. But here's the golden rule. Your front number, a, cannot be 10 or bigger, and it cannot be less than 1. It must sit perfectly between 1 and 9.99. Let's play Find the Flaw. If Sam writes 72 times 10 to the power of 3 on his paper, what's the flaw? The 72 is too big. If he writes 0.72 times 10 to the power of 5, the flaw is that 0.72 is less than 1. It absolutely has to be adjusted to 7.2. Do not drop marks on this technicality. And remember that negative index survival tool we learned a few minutes ago? It comes back here to brilliantly represent incredibly tiny decimals. An ordinary number like 0.0032 is frankly exhausting to look at. But in standard form, we move the decimal point 3 places to the right to get our front number perfectly between 1 and 10, which gives us 3.2. Because we are dealing with a tiny decimal, a number smaller than 1, our power of 10 must be negative, so it perfectly translates to 3.2 times 10 to the negative 3.
Finally, we've arrived at Section 6, Calculating in Standard Form. Translating these numbers is one thing, but your exam will absolutely command you to calculate with them, to multiply, divide, add, and subtract them. Let's lock in this final strategy.
Let's start with multiplication, which is surprisingly satisfying once you know the steps. Imagine a 30-second speed-solving timer on the clock. We have 2.4 times 10 to the 4, multiplied by 5 times 10 to the 7. Step 1. Multiply the front numbers together. 2.4 times 5 equals 12. Step 2. Use our very first index law to combine the tens. When multiplying, we add the powers. 4 plus 7 is 11, giving us 10 to the 11th. So we have 12 times 10 to the 11. Are we done? No. Sam would stop here and lose the final mark. Why? Because 12 breaks our golden rule. It's bigger than 10. We must apply the final stage of our framework and adjust it. We change the 12 to a 1.2, making the front number 10 times smaller. To balance that out, we must make the power 10 times bigger, bumping it up by 1, giving us a perfectly formatted final answer of 1.2 times 10 to the 12.
Now, addition in the wasteland is much trickier. You literally cannot just add the front numbers if the powers of 10 are different. It's like trying to add centimeters to kilometers without converting them first. The secret strategy is changing the indices to match before you even try to combine them. We take 3.8 times 10 to the 6th, and we convert it into 380 times 10 to the 4. Now that both parts end in times 10 to the 4, we have common ground. We simply add the front values, 380 plus 8.7, to get 388.7. Finally, we must adjust that back into strict standard form, shifting the decimal 2 places left to give our final perfect answer, 3.887 times 10 to the 6th.
You might be asking, why do we put ourselves through all this standard form training? Because of numbers exactly like this, 3 times 10 to the 8th meters per second. This isn't just an abstract number generated for a math test. This is the literal speed of light. It shows exactly how these mathematical tools apply to real cosmic physics and engineering. The universe operates on scales far too large or small for normal numbers, and mastering standard form means you speak the language of the universe.
So I leave you with this final provocative challenge, one that combines everything we've done today. If a star is 300 light years away, and you now know the speed of light, are your standard form tools sharp enough to calculate that immense distance in kilometers? Listen, students who implement these mathematics strategies, decoding the command words, applying the step-by-step logic, and managing their time, see an average improvement of 2 grade boundaries. But only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. And before you go, drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. See you in the next strategy session.